Right, welcome back, and we're going forth talking about chemical equilibrium. Now, we're talking about the forward and the reverse reaction. Now, if the forward reaction in a reversible reaction is exothermic, then the reverse reaction will be endothermic. Or vice versa, if the forward reaction is endothermic, the reverse reaction will be exothermic. What do we mean by this? If you go back to the potential energy diagrams, okay, in kilojoules, energy in kilojoules there, and your reaction coordinate here, okay, and you drew a graph like this. You had a graph like this. Remember that graph? Yes, where you've got your reactants there and your products there. This graph here, by me looking at it, I can see that going forward, this is an exothermic reaction because the energy of the product is less than the energy of the reactants there. So it's an exothermic reaction to the right, forward. So your forward reaction is exothermic. Then the reverse reaction has to be endothermic. In other words, taking it from this side now, having your reactants there and having your products there. If you go back there, that shape tells you this is an endothermic reaction, because at this point in time, the energy of your product will be greater than the energy of your reactants. And therefore, you'll have your delta H being positive, meaning you've got an endothermic reaction. Now, a state of chemical equilibrium can be disturbed. Remember when we started that graph leveling up there, that leveling up that shows chemical equilibrium, that state of chemical equilibrium can be disturbed. And what happens when it is disturbed? And what are those factors that will affect or can be able to disturb a state of chemical equilibrium? Here we're looking at a principle, very important principle by Le Chatelier, where he says, when the chemical equilibrium in a closed system is disturbed by changing any conditions surrounding it, the equilibrium will shift in such a way as to cancel the effect of that change of condition. And what are these conditions that Le Chatelier is referring to? There are three conditions. We've got concentration, we've got temperature, and we've got pressure. And now let's look at concentration. If you have got a reaction A plus B in equilibrium with C, if I decide to increase the concentration of A, the equilibrium would like to deal with that disturbance. In other words, they must get rid of that excess concentration on A. And what is the state of equilibrium going to do? It's going to begin to eat off the excess here on A, so that you're going to have more of more of C forming, more C forming. And if you've got excess there, most of B is going to be eaten away. So this one will be, B becomes less, whilst you increasing. You are increasing A. And when you increase A, then B would like to react with the excess of A. So amount of B at equilibrium then goes down, and more of C obviously has to be formed to be able to take away the excess A there. That's what concentration is about. Now, in the same way, if I inject more of C here, because it's a state of chemical equilibrium, remember, so I can go reverse. This excess C would have disturbed the equilibrium, and therefore more of C is going to disintegrate to give me A and B. So more A and B will be formed. So the quantity of A and B is going to be more there. Okay. Another factor that affects a state of chemical equilibrium is temperature. Now, temperature is associated with heat. If you want something to change temperature, you can heat it up so that the temperature of that system increases, or you can cool it off, put it inside the fridge, or place it in a pool of ice blocks where the temperature of the system is going to go down. So you are playing around with heat. Now, what do we know about heat? In a chemical reaction, when we're talking about heat, we're talking about heat of reaction, delta H, and therefore, if you're taking energy out or putting energy in, it means you will be tampering with with the type of the reaction that is happening there. Now, what do I mean by this? If you increase temperature, you are putting more heat into the system. So by putting more heat, you will be favoring the side that is endothermic in that chemical equation. Why? Because the excess heat has to be taken in, so you're pushing the equilibrium towards the endothermic side of your reaction. Remember, either the reverse or the forward is going to be endothermic. The other one has to be exothermic. In the same way, you decrease temperature, you're going to push this towards the exothermic side of your chemical equilibrium. Pressure, on the other hand, here you have to be talking about gases. If you increase pressure, okay, if you increase pressure, you will favor the side with smaller volume, side with smaller number of moles. Okay, smaller number of moles. We normally would call that smaller volume. Now, quickly as we close up, look at this equation here, this graph here. If you've got a state of equilibrium here, something has happened on T2, so disturbance. If you have a sharp thing going up, it means increase in concentration. If you have something gentle like that, it could mean temperature, it could mean pressure in that way, okay, but not concentration. This brings us to the end. We'll talk more about this in coming lessons. Keep well and wish you well. From me, bye-bye.